Hello everybody and welcome to today's Happy Maths Hour, which is live from Sheffield and Cambridge. And we are in preparation for the Global Maths and Science lesson, this year's annual Global Maths and Science lesson. It's our 7th one. We started in 2015 and each year we have a different topic. This year the topic is playing fraction games. So we're going to learn a lot about fractions by playing the game. So please do sign up for the Global Maths and Science lesson.
We'll tell you more about it later.
We will, but I'm going to leave that running at the bottom there. So there's the sign up link, and it's also in the description, depending what medium you're on. It'll be somewhere around. You'll find the description and you click on the link. So
this is Happy Maths. This is Happy Maths Hour, and we're going to talk about fractions. It's such a troublesome subject to teach and learn. So many children hate fractions, and it's because they don't understand why they've got to do this and that, turn something upside down and multiply instead of dividing. They learn these rules, and the rules don't make any sense. So on the Aiming High website, we have got a collection of fraction activities and games, and if the children are taught this way, they will understand fractions. They will take the fear out of fractions. You're playing fear. So you're not all teachers, but there you go. This is what we think about fractions. Did you enjoy learning fractions? Did you hate learning fractions when you were at school? Let's look at fractions again. And here we go. So what we're going to do is we're going to talk about a fraction wall. And we're going to talk about building a fraction wall from top bottom, which is a unit, and then smaller and smaller and smaller blocks as we build up the wall, and each block is a fraction of the unit. Now in this picture, we've got a purple unit at the bottom, and then we've got 2 blue halves, and we've got 3 brown thirds and 4 green quarters, and then that color, which is a sort of rather shocking pink, I think, that one is 6, and the next one is a lighter green, and so on. That's 8ths, and so on. And so you can build your own fraction wall, color it, make it out of cardboard, whatever. And it's a really good thing to have on your classroom wall to remind children of these fractions. And it helps with equivalent fractions. What's the same as something else? All that about cancelling fractions that they are told the rules about. And it also helps to know, is this fraction bigger or smaller than that fraction? So did you enjoy learning fractions at school, Caroline?
I did. Fractions was one of those things, one of my lovely puzzles. I loved manipulating them and figuring out what goes where and how to add them. I find it very exciting, finding the correct common denominator. I was like, "Way, found it! Now it works."
Did you understand why when you divide a fraction by another fraction, you turn the second one upside down and multiply?
I discovered it was just an algorithm. I discovered it in my 40s. That I actually didn't understand division of fractions. So yeah, it was just an algorithm. It was just a method.
Yeah, I mean, a lot of children do eventually understand adding fractions and subtracting. Multiplying is always easy; it's the obvious thing. But often they, as Caroline says, it's just an algorithm, just a rule. You do it, and if you're careful, you get the right answer. Yes. Okay. So here we go. Here is a puzzle, which at a glance it looks like the wall you've just seen or similar, but actually the strips are now in a muddled sort of order. They're not in the right order. So Caroline's got the strips on this Aiming High activity called fraction wall game. You can cut out the strips, and then you can the children can rearrange them to be with a unit at the bottom, and then the halves, and then the thirds and quarters and fifths and sixths and so on. So there's the puzzle. That's what it's about. It's quite easy to do. Possibly in the class, each child can have their own cut out strips and stick them in their book, and then write on each block, or at least one on each row, each layer, one, a half, a third, a quarter, a fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. So this only goes up to 12ths. It's the red ones are the 12ths, and that goes right on the top. And so they're quite narrow strips. You may want to make your own in your own way and make it with wider, chunkier strips, and have your fraction wall to refer to. Or you may just use this as a puzzle and make a fraction wall that's a solid thing and not cut up, and it's nice and neat and tidy.
It's good for assessment, isn't it, Tony? You can walk around and if the children are doing it in pairs, then it's really good to establish whether or not they're understanding what's happening. I made a discovery as well. What discovery? Something that I'd never really thought about. I was building one with an existing system that only has ones and twos. So I thought, well, to make two, that's two of those, that's 2/6 to make two, but they've only got those certain lengths. So okay, so I've got 12, so I can divide it in two, and I can divide it into 3 12s, but I can divide it into 4 12s. I can divide it into 5 12s. No, can I? That was the question. Can I divide it into 5 12s? So I was happily going along. I mean, I do know the answer, but this is a great activity for kids. Can you divide it into 5 12s? Can you divide 12 into 5 units? 5 equal, not units, 5 equal whole numbers. Can you? And you can.
No, it says five fractions.
If you can divide it into 5 fractions, but will they be whole numbers? Is what I meant to say.
I don't think you mean whole numbers. I mean, will they be whole strips?
I agree. They'll be whole strips the way you did it, but I got these, and they're these. You only have whole numbers with this. This is a different activity. Just a thought that you only have whole numbers, and so can you divide 12 into 5/5 and still have whole numbers? Is 1/5 of 12 a whole number? And this is a nice way to look at it. So what happens if you put the 5th one in? Whoops, there's a remainder.
It's more. It goes beyond the unit, as it were. It goes beyond. Yeah.
And if you use, because each one of so if you're working on whole numbers, you can see what the remainder is and which ones divide into 12.
So what Caroline has got there, I think, are what you call Cuisenaire rods. They used to be around in primary schools quite a lot. I don't know how many primary schools have got them now. But as she says, they're rods of so many units in length. And so they have a lot of uses, and fraction, you can use them for fraction work. But they don't particularly, they don't particularly lend themselves to this exercise, because if we want to divide into 12ths, we've got to have a unit that we can easily split into those sections, and that's why we do them with the cards and the cardboard and draw our own. And also we do believe that expensive equipment is absolutely not necessary, and you can make your own with scrap paper, scrap card, and a lot of the schools we work with as AIMSEC don't have money to buy equipment, So we don't even show them things like Cuisinette rods because
Well, I was actually going to make up some cardboard equivalents, Tony. And then when I did it, because I hadn't thought it through, when I actually went to do it, I realized, oh my goodness, this is not. I realized this isn't a suitable pot for this activity. So I thought, well,
we
okay,
can
but
work
this
on that,
does
Caroline.
show, but this does show it's a different activity, and it does show other things very clearly. So that was, I just wanted to share that.
We can work on that, Caroline, I think, and I good idea we could work on. Yeah. Okay, so here the idea is it's just a puzzle, and you can do this with quite young children because they are putting something in order. They don't even need to know what the fractions are or know that there are such things as fractions, because for them they're putting them in an order from the biggest one at the bottom, making them as they put the strips together. They want to be in order, getting smaller and smaller and smaller as you go up. So this is a prelude to learning the word fraction, okay, for little children. And another thing we like to do is to show how the same theme can goes right through our learning, and we keep adding to that theme. So this is an excellent way to lay the foundations for small children. And then later you can mention fractions and bring that into the talk and into the vocabulary, especially
Tony, your sound.
So you just keep to certain strips. The first time you really start to talk about fractions, you could just use the unit, the halves, and the quarters, and no more, and talk about what they were and how many quarters made a half and that sort of thing.
Tony, your sound
6 or 7. When they
your sound has gone. Tony,
just do it as
can't
a
hear
puzzle.
me. Okay, she can't hear me.
Now, here is the same puzzle, but now we want to work downwards rather than upwards. That's the only difference. So Caroline is going to put the unit at the top now. Oh, she's got the unit at the top. The one that we were doing before, Caroline, had the unit at the bottom.
That is correct. Tony, can you hear me? You can't hear me. Okay, we'll just
what you're doing, Caroline. What we need now is exactly what you had a minute ago, and then you muddled them up. There you go. With this time with the 12th at the bottom. Okay. The last one, this one, we were supposed to do with the unit at the bottom, and then do it with the 12th at the bottom, as Caroline's now done. You see the right, which hasn't got as many layers in it, and then we want you to think about marking the scale on the bottom. Can you see 0 or 0 over 6, 1 over 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6? Well, on our wall that we're going to do with the puzzle, you can do that with 12, and so you mark it with 12 as you go along there, and Caroline is doing it. Don't need to go all the way along, Caroline. I think we've got the idea. So are you up to? We can't actually see. That's 6/12. You just written a 6. That's 6, I think. Is it 6/12? And then okay. So then now underneath that, do another scale. But now don't put 2/12. Think what is the equivalent fraction to 2/12? That's what we call cancelled or in its lowest terms. Well, you should see that 2/6, that 1/6 is
is the same as 2/12. So Caroline's going to write, instead of 2/12, she's going to write 1/6. And instead of 3/12, I think she should have written a quarter. I can't see. No, I don't think you got it right, Caroline, because it's 2/12 is a 6, 3/12 is a quarter, and 4/12 is a third. And I think you wrote them in the opposite order. You? Oh, no, you did them right. So sorry. It's just that it's very small and it's difficult to see. That's perfect, Caroline. Lovely. Okay. So, so there'll be a lot of talk and chat about that when you do it with young children. And you don't do it. I said the wrong thing. They do it with a little bit of coaxing from you as a parent or a teacher. Yes, I'm sorry, Caroline. Did you want me to share, stop sharing so we can see that a bit better, or do you think that's good enough, Caroline?
You can't hear me. I don't know who can hear me and who can't. I don't know if anybody can hear me. You can't hear me. I'm speaking and you can't hear me. It's not working.
We can't hear you, Caroline.
I know. Okay, I'll leave and see what happens.
Can you hear me? Well, I'm going to continue. I think Caroline's having some trouble with the sound.
Can you hear me now?
No, we can't. I still can't hear you, Caroline. Well, I'm going to just continue anyway, because I'm going to show you this, these are called Multilink Cubes. And you can see it's a fraction wall again. This is a lovely thing to do with young children if you've got this these interlocking cubes that you can click together. You can do this with Lego as well. So a lot of households have got Lego. Well, the lucky ones, not in South Africa with the schools where I work in South Africa, but if your children have got Lego or your school's got Lego, you could do this with Lego. And what you've got there, you see you've got unit, the halves are different colors, pink and brown as in this picture. The thirds are different colors, orange and yellow. The quarters, again, green and gray, and fifths and sixths. So that's a nice activity for young children with Multilink cubes. So Caroline, can we hear you? I don't know what's happened to Caroline's sound. Well, I can't hear Caroline, and I don't know whether people can hear me. I do hope they can. Perhaps you put it on the chat, whether you can hear me and whether you can hear Caroline. So if you're out there, so Caroline's written, can hear you. Well, my goodness, I don't know. This technology, you see, we are trying to be IT experts, well, not experts, but you know, what we're trying to do is we're trying to do the technology, and the technology now is letting us down. And we're using StreamYard, and I'm afraid we have to blame StreamYard, because when we use Zoom, we don't have so much trouble. So we'll probably have to cut this out of the recording. I could leave and come back to see if I can improve my sound. And I'm really sorry to be doing this, but I'm going to leave the studio. Caroline, you can let me back, I hope.
Well, if you can hear me, then hello, Antoinette, and hello, Temba. Thank you so much for joining us. And so please say on the chat again, just to confirm that you can hear me. I'm waiting for Tony to come back in. we had sound problems earlier and we thought we'd fix them, and then she couldn't hear me. So please say if you can hear me again, please. Temma, if you can say, hello, Antoinette. Can you hear me now? Oh, hello, Marvisto. Is it Marvelous? You were on the session on Saturday. Right. So can you hear me, Tony? Can you hear me?
What a shame.
Okay, Antoinette can hear. And can you hear Tony, Antoinette?
Can you hear me, Caroline?
I can hear you perfectly. I'm going to send her a message. Private chat. Let's put that in there. Okay. I can hear you. And the audience can hear us both. I'm sending that message to Tony. Hear us both. Go ahead and present. I'm just going to be quiet and let Tony present. I will prompt me on the activities.
The joys of modern technology.
Prompt me for the props.
Caroline's in charge, so I'm going to blame her. She's in charge of the technology.
Oi!
Well, I'm useless, and she's much more techie minded than I am. After all, she's an engineer. My goodness.
Do you know, I could shut her up. I could press the mute button so you don't.
And they're ideal for young children. Now I'm going to tell you about chocolate fractions. This is a nice activity for young learners, and it's a story. So here's the story. Its writing I know is small, but I'm going to read it to you. Your granny bought a bar of chocolate marked into 32 pieces and weighing 180 grams. How many pieces make half the chocolate? How would you find that out? Caroline, could you break your bar in half? So the story goes on. How many pieces make 1/4? What fraction of the bar is 1 piece of chocolate? So these are little questions for the learners to answer. It's a story. So that's Granny, gave you and your sister 2 pieces each to eat. Yummy. What fraction have you and your sister eaten? How many pieces are left? What fraction of the bar is that? Now, Granny needs 90 grams of chocolate to make a birthday cake for you for your birthday. Wow, that's exciting. How many pieces of chocolate will she use, and how many pieces will be left over? What fraction of the bar is left? Will there be enough chocolate for your family each to eat 2 pieces of chocolate? And if so, will there be any chocolate left after that? So there's the story, and there's one of a large collection of different activities on the Aiming High website, and they can download a worksheet. You can download the notes for teachers with solutions and lots more on fractions on the Aiming High website, the Aiming High network, we call it. Now we're coming to the double 6 game. So Caroline, this is going to be a bit tricky as I can't hear you. And I'm not sure why I can't hear you, but there you go. So what we're doing to play this game is you need 2 dice or a 1 to 6 spinner, and there Caroline has the wall, and the children will use the wall to compare the size of fractions. Now, Caroline, throw the dice. This is your throw, Caroline. Right, so you've got a 1 and a 2. Now, Caroline's got to make a fraction, putting the smaller number on top and the bigger number underneath. So her fraction is a half. Now, remember that, so she can show a half on the wall. Now, throw it for me, Caroline. My turn. Caroline's going to throw for me. Throw the dice for me, Caroline. And what have we got? One quarter. Yes, 1/4. And Caroline wins because this is the round. We both teams, both players throw and make fractions, and the bigger fraction wins. The larger fraction wins. So Caroline's won. So, oh, is that your? No, that's mine. Now throw again for you, Caroline. You've won that round. Now you have got 2/4. Now, now you've got to look at the quarters and decide what 2/4 would be. And 2/4, don't see quarters. Oh, the quarters are dark blue. So what do 2 dark blue pieces make? And you can see that 2 dark blue pieces are the same as a light blue piece, which is a half. So that's Caroline's fraction. Now my fraction, Caroline, is mine going to be bigger or smaller than yours? What have I got? I've got a half. Okay, so that's the same fraction. So that round was a draw. So in the first round, Caroline won, and in the second round, we were the same. We both got a half. It happened that way. Right, again, it's your turn again, Caroline. Now Caroline's got a third. And those are the sort of cream-coloured pieces, a third. Now, will you throw for me, Caroline, and see what I get? Caroline, is that dice a fair one? Because you keep, every time you seem to get a 1 and a something else, which is very odd. Oh, I think we did get a 2 once. Okay, so that's 1/2, and my fraction, which is a half, is bigger than Caroline's, which was a third, and I won that round. So shall we do it once more, Caroline? Just once. What have we got now? Oh my goodness! Why does one? It's a loaded die you've got there. Caroline has got a 6. I think I've got a very good chance of winning. Okay, Caroline. I've got the biggest possible. I've got 3/3, okay, and my 3/3 is a whole unit, so I would have won that round. Really fair square, and certainly I would have been the winner there. So there you go. So this game is a game which even small children, if there's some help with doing it, can learn to play and compare the fractions, as Caroline has put the strips there to seat and counted the halves, the thirds, the quarters, and to see which was the bigger fraction and which one won the game, or the round, not the whole game, but the round. And so this is a good game for 2 teams. So if there's a group of you, you can have Team A and Team B, or Team Tony and Team Caroline, and take it in turns, and 1 round is just 2 throws, and you see who's won. Or if you've got a small number of people and you're sitting around a table, then this can be a game that everybody joins in on their own behalf rather than a team game, and you can pass the dice round and each person can throw the dice. Okay, so you can vary this, and here on this slide you see how to make a spinner. And now a spinner, all you need to then is to make the polygon which will have the right number on it. So supposing you've built a higher wall up to 9th, okay, and so you need to find the numbers 1 up, instead of 1 up to 6, this is 1 up to 9. And so you mark your polygon, which has 9 sides, with the numbers 1 to 9. And you need an ordinary paper clip, which you straighten out one end, and then you can use a thumbtack in the middle, or you can just hold the paper clip in the middle with a pencil, as you see on the picture there, and then you can just flick the paper clip, and it works really well. As it spins round, it will stop in one of those sectors, and that's your number. So you have to spin it twice to get the fraction. So rather than using 2 dice, you've got to spin twice. And you can hear this is walls of different heights. So what I suggest is that if you're in school, as you're working with older children, as they move up the primary school, maybe into secondary school, you actually introduce more fractions here, and they will learn in an amusing way, a way they will enjoy. They will learn about equivalent fractions which are actually the same, and cancelling fractions, and they will learn about also comparing one fraction with another. I mean, is 2/3 bigger or smaller than 5/12, for example? So you can show that on the fraction wall, and you need to do it. You need to be able to find an answer to that question if those numbers come up in the game. And so it gives you a reason for wanting to have an answer to that. Otherwise, it's just a boring question. You know, is 2/3 bigger or smaller than 5/12? So what? What does it matter anyway? You know, just as an exercise, how boring. But if you need to know which is bigger, because if the bigger one wins the game, you've got a reason for asking that question, and you've got a reason for finding the right answer. Okay, so vary your fraction wall, building it higher, up to 20th if you like, that's up to you. Make your own fraction wall. So here are some questions that you can ask. And these are questions to help the learners to understand how the wall works. You see a picture of the wall built correctly now. Caroline, if people can hear you, do you want to talk about key questions? Because I've been talking a lot.
As Tony knows, key questions are one of my favorite things. They are so powerful because you're not asking closed questions. You're not asking, is 5 + 5 10? Or what fraction is 1 part of in 12? Oh, now I've lost the slide. Okay, so the great thing about the key questions is that and all the aiming high activities give you key questions to use. So if you're not sure or you're just learning to use them, you can just go onto the Aiming High website, and I'm going to put the key questions here in the visualizer because I don't think Tony's noticed. This is the craziest session we have ever done. I think we've had some crazy ones, but this is even crazier. So the key questions are open questions. What do you notice about the length of the different building blocks in the picture? So you're not, actually, I think I may as well remove that from there because it's not helping you at all, is it? So what do you notice? These are the key things. And these questions are leading you to understanding, or helping you to lead the learner to understanding how many dark green blocks are there. So yes, that's a closed question, but these are leading you to understanding. So how many dark greens are there? How many of the orange blocks match the unit grey box? So how many of the orange are needed to match the unit grey block, which is the unit? So it's effectively the same question, but it's asked in a different way. And if the bottom, the grey block, is 1 unit, then what fraction is the purple block? So it's asking it in a different way. Instead of being really blunt with the questions, you're going to it slowly but surely. And then how many blocks of this colour match how many blocks of that colour? So you're looking at different colours, so they can choose two blocks of their own, and they might make discoveries like, I mean, I do understand, I just didn't think about it when I got these out, that they might make some discoveries that will stand them in good stead forever and ever, that you can't, the 6 twos do work, but there was actually, that one was wrong. There was 6 twos do work, but 6 threes, fifths, if you had 5 units, that was not going to go into 12, for example, and that would be a discovery if they started investigating that. If they had, so for the 5 1 2 3 4 5, if they were unit blocks, would that go, and do they go into each other? And then that, this is a huge question at the end. How do you know? So it's not just a matter of asking the questions. It's a matter of, then please explain it to me. What is the answer and why? How do you know? And how do you know is a very powerful way of saying why. And if you say why, you can get a blank response. But if you say, how do you know? Then they'll start thinking about, well, how do I know? And they'll ask themselves that question, how do I know? Rather than why. It's like, whoa, why? I'm not sure. But how do I know? Is it open, so open to the point that you will actually get responses to how do you know? I'm going to go back, and Tony, hopefully, we've got that back. Okay, hopefully Tony will get the message, but it's over to you, and I will put myself back on.
Okay, I'm going to talk about this global maths and science lesson. We mentioned it at the beginning. We have done this for 6 years. This is our 7th year. We've had over 10,000 participants, children all around the world, doing this same lesson on the same day, which is very exciting. And it's much more than just a maths lesson, because they are aware, if their teachers talk to them and they talk to each other about, that there are children in America, in North and South America, Canada, Australia, India, Europe, Africa, in the Caribbean, all around the world, doing this same lesson on the 23rd of September, it will be this year, and sharing together something that, you know, brings the whole world together. And you see our G10 symbol, which has a picture of the world, the globe, with children holding hands all the way around the edge of our G10. And this is an activity which children have enjoyed year after year. And it's just 30 minutes. And you can do it at home if you like. You've got a group of people interested at home, or you can do it in school or anywhere else. Just 30 minutes. Everything's easy to follow. We give you all the directions. If you register there, you see the link on Bubbly Math. The first year, 2015, it was on DNA, on the double helix. And the children there in the picture have made a double helix. How clever is that? And the next year it was on maths and sport, so much to do with number and speed and height you can jump and all these statistics to do with sport. The following year was about time. It was about estimating time. And if you think that the teacher in that picture is up in the air, she is. She's doing star jumps, and everybody had to estimate how many star jumps they could do in a minute. And it was fun. It was just fun. The following year it was all on bubbles, which is one of Caroline's specialities. That was great fun. In 2019, it was on fractals, and we made these giant tetrahedra. There's the Spinsky tetrahedron. And last year, we decided to have it on women in science because of Florence Nightingale's 200th anniversary. And she is in the middle of that picture there with the nursing school that she founded in London, which was the first nursing school in England, way, way, way back. Not 200 years ago, that's when she was born. But anyway, she started this nursing school. And we had decided to do it on health stats long before there was anybody knew about COVID. So it was very topical last year. So this year, it's going to be on build a fraction wall. So the activity that we talked about earlier in this session, in this Happy Maths Hour, is the first activity. Cut the strips and make your wall. And then the second activity is to play with the younger children, to play the game with a wall that goes up, only up to 6. But the teacher can choose, and we'll offer them a selection of different walls that they can choose from, and they'll need to make a spinner. And there will be a little video to show them how to make their own spinner. But I think the directions were there, as they were there, were quite clear as we showed you. So that's what it is this year. Now, we always ask the teachers to send us a photo of their lesson. And there you see a class that was actually in India with their tetrahedron that they made, a Sapinski tetrahedron, and lots of small tetrahedron that the children made and then built up. And they used these smaller ones to make an even bigger one than the one you see in the picture. And so each year, to prove that you did the lesson on that day, the teacher sends a certificate, sends a photograph of the class with whatever it is doing the activity or whatever they've made, showing what they've made. And then the teachers will get certificates for their groups. So they can have one certificate that's written for the whole group that can go on the classroom wall, and one certificate that the teacher can put the children's names on and then print them if the teacher decides to give each child a certificate. So this is our global maths and science lesson. It's next Thursday. Caroline.
Just you get 2 certificates. You print out as many as you like, so you can put all the children's names on.
And did you say that there's a large collection of follow-up activities on fractions on the Aiming High website, which there will be links for, so that half an hour is all you need to do for this one lesson, but if you want to, you can use our other activities. Now, this is the very last activity. Caroline, what do you think of this?
I love this activity. One of the things that distinguishes mathematics from everything else is that amazing ability to visualize and to go to infinity. We can't go to infinity in our lives. We can't go to infinity in distance, in time, in anything except in our heads. And this activity does 2 things. It helps you visualize fractions. So what you do is you keep on halving. You're aiming for the end of that bar and you keep on halving. And number 1, will you ever reach the end? But in the process, you're halving fractions. So you're doing some really interesting mathematics, which is also a binary progression, which is by the by, but it's a very useful observation. And it takes you to infinity. And I just love the fact that we can go to infinity by using our imaginations, and the the reason why visualizing anything, estimating and visualizing in particular in mathematics is so important is that we need it to actually do the maths in a lot of cases, and this is one of them.
I'm trying to lip read what Caroline's saying. So what you have here is adding an infinite sequence of fractions, as Caroline, I'm sure, has been telling you. What an abstract idea, an infinite sequence. And we're able to go to infinity in our minds. And so what we're doing is visualizing this limit. It's something that we talk about, the mind's eye. And there's an eye, and this has got Egyptian fractions in. Now, what's Egyptian about those fractions? Well, you see, this exercise, this activity is all about adding 1 plus a half plus a quarter plus an eighth plus a 16th plus a 32nd plus a 64th, and on and on and on. And each one you add only takes you halfway to the end of this strip. But you get so close, and you get closer and closer in the limit, which I'm sure Caroline has just it out. And what you see in the eye there is written a half, a quarter, and then an 8 is in red, and a 16th is then inside the white of the eye. 1 over 64 is in green, and 1 over 32 comes first in blue, and then 1 over 64. Now the Egyptians, that's called the Eye of Horus. Caroline, the Eye of Horus.
What I wanted to say was that the Egyptians, apparently, I only just learned, they didn't use fractions the way we do. They didn't have 5/6 and they didn't have 7/8. They only used the fractions that you see there. It had to be 1 over the fraction, which means that they were really, really, really good at adding fractions and working out the common denominator, because the only way they could work out 5/6 was to work out what fractions you had to add together with a 1 on top to make 5/6. And I suppose they could have added 5/1/6 together, but something tells me that they did things like adding a half and a sixth together to make not 6, but half and 2/3. No, that's 2/3. No, see, wouldn't be. It'd be half and 1 something, which isn't coming to me. But yeah, I love that.
Yes, well, I'm getting very good at lip reading. Caroline's been explaining to you about Egyptian fractions. I think it's quite intriguing. They were very sophisticated people, and they obviously understood about fractions. But the way they used fractions made the whole process, the whole procedure, a little bit more difficult, I think. In some ways and easier in others. But anyway, that's Egyptian fractions for you. But there you are. And it's visualizing. And of course, the sum of this infinite sequence becomes a series when you add up the terms, and the sum in the limit is 2. So this lovely strip isn't like the fraction wall that we built, but it's the same idea. We're using blocks to show the fractions, and these smaller and smaller blocks are in order, aren't they? And each one is half the previous one, and I've got a lovely demonstration there that this infinite sequence adds up the limit anyway. As the number of terms tends to infinity, the sum tends to 2. Just 2. The answer's simply 2. Isn't that just absolutely lovely? So we've enjoyed a lot of ideas about fractions. I hope you've enjoyed it too. There's lots of games to play, and the sorts of games that you can vary quite a bit and talk about and become more familiar, make friends with fractions. So I think we've about time to say goodbye. Until
Goodbye.
next week. We'll see you on Happy Maths Hour next week at the same time.
Thank you for joining us. We've had some participants from the current course that AIMSEC's doing. It's so wonderful to see you. Thank you for joining us. I hope it worked out for you, and we will be working on, please do get your schools to sign up for the global maths lesson. It's still going down on the bottom there. It's in the description. Please click on that link and sign up your school, or if you've got learners at home, whatever, it doesn't matter where it's done. Every child can do the lesson. As you saw how simple it is. Sign up, let us know what the numbers are going to be, and then afterwards you report your numbers back to us, you send us a picture, and then we'll send you the certificate of participation so you can print it out and write the children's name on it. Thank you very much. We'll see you next week for another Happy Maths Hour, and see you next week for the Global Maths and Science lesson on the 23rd of September. Thank you very much. Oh, there's two more comments. Oh, thank you, Antoinette. I'm glad you loved it. Yeah, we really had to. We had silent communication between us. We managed it finally. Goodbye. I'm guessing that's Cynthia saying goodbye from me until next week. I'm guessing that's Cynthia because of the way it comes up. It doesn't show me your name. Take care. See you all next week. See some of you on Wednesday.